Hey, we're doing some practice problems, and the first one we're going to evaluate some function values. So the first one we've got f of -2 is equal to 4x minus 6 plus x cubed. And we're going to take that -2 and we're going to place it everywhere there's an x. So in evaluating that, we'll have 4 times -2. And then we'll have minus 6 plus -2 cubed. So we'll use our little calculator. So we'll have -8 minus 6 minus 8, and I believe that gives me -22 in the end. Okay, so -2 went into the function, -22 came out. B, g of 3 equals 2 times the square root of 16x plus 1. So we're going to plug 3 in. So this is going to look like 2 times the square root of 16 times 3 plus 1. So that's going to be 2 times the square root of 49 if you evaluate that, which will be 2 times 7, which will give you 14. So 3 goes in, 14 comes back. So that's kind of like an x-y combination. X is 3, y is 14. C of 4, 4 is our input, is equal to the quantity of 2x plus 1 squared. So we're going to take the 4 and we're going to place it everywhere we have an x. So that'll be 2 times 4 plus 1. Then when we get that total, it'll be squared. So basically that will be 9 squared. So that'll be 81. So 4 goes in the function, 81 comes out. So we're just evaluating functions. Let's see here. Let's slide down. The next set of problems are a couple of graphs. Sorry, it's getting a little weird. For the first graph, it says find the x and the y intercepts and state the regions the graph is increasing and decreasing. So we got several things to do here. But first of all, let's do the intercepts and know that x-intercepts happen on the x-axis. So we'll hit all the points where we're touching the x-axis. So the x-intercepts are the points -1, 0, 2, 0, and 4, 0. And then the y-intercepts are where we're hitting the y-axis. Remember, for a function, you can only hit it once. It looks like it's about 0, -4. Okay. And then if we want to talk about the increasing regions, we need to figure out where the function is going up from left to right. So I'm going to trace the graph from left to right, and if my finger is moving up, that's an increasing region. So that happens from, I lost it, from -infinity to -1. It looks like it happens again from -4 to 2. Excuse me, that's not -4 to 2, that's 0 to 2. And it looks like it continues to go up after 2, so from 2 to about, I'd say 3.5. That's an estimate. So 2 to 3.5. And remember, those are intervals, not points. So the x and the y intercepts are points, x, y. The increasing and decreasing are intervals, so from a starting x to an ending x. So it's decreasing here where it's going down from left to right. So from 1 to 0. Let's do that in a different color. From -1 to 0, I'm sorry. And then from this 3.5 to infinity, we think it is going down. Okay. So just be careful there. Okay. B here, a different graph. X-intercepts, it looks like there's one at -3 and one at 5-ish. So let's see here. We'll say the X-intercept is the 2 points, -3, 0, and 5, 0. The Y-intercept, where we cross the y-axis, which looks like it happens at about 90. So that would be the point 0, 90. Excuse me. And where's it increasing? It's increasing where we're going up from left to right. So if you have questions about that, make sure you don't be too scared to ask them. But when this thing starts, it's coming down, but at -3, it starts going up to what looks like about 2.5. That's an estimate. But let's just say it's happening from -3 up to about 2.5. And then it's decreasing most of the time. It's decreasing when it starts. It's coming down from -infinity to -3, and then from wherever my 2.5 is on, it's going down. So let's see if we can write that. So from -infinity to -3, and then also from about 2.5 to infinity. So lots of regions where it's going back and forth, but make sure you see all those points very well. Okay, and the next thing we talked about was, having trouble here. Okay, well, we're still talking about intercepts, but we got some different functions here. So let's try and get them for these three functions. So the first function is y equals 7x minus 4. So remember, when we do an x-intercept, we let y equal 0. So in that case, 0 equals 7x minus 4. And if we get x by itself, it would be x equals 4/7. So that's the point 4/7, 0. And then when we do a y-intercept, we let x equal 0. And in that case, we got y equals 7 times 0 minus 4. 7 times 0 is 0, so y equals -4. So we get the point 0, -4. Okay, so there's our two intercepts for the first one. 4/7 for the x and -4 for the y. B here, f of x equals 4 times the square root of x plus 2, and then minus 16. Again, if we go for the x-intercept, we let y be 0, which is the same thing as letting f of x or the function be 0. So we'll have 0 equals 4 times the square root of x plus 2 minus 16. We need to get that square root by itself. That's an algebra question. So we're going to add 16 to both sides and divide by the 4. So we'll have 4 equals square root of x plus 2. So I added the 16 over, then I divided by the 4 out front. And then I'm going to square both sides to get rid of the square root. So I have 16 equals x plus 2, so x equals 14. So that's an x-intercept of 14, 0. And then, of course, my y-intercept, I'm going to let x equals 0. So when I plug in 0, I get 4 times 0 plus 2 minus 16. That doesn't give me anything nice. I'm going to let it go to the calculator. So 4 times the square root of 2 minus 16. Looks like it gives me about -10.3. So that's what I'm going to do here. I'm going to say the 0, -10.3. And that's kind of an estimation because I rounded off. I could still use the 4 square roots of 2 minus 16. That's a better exact number, but if I was plotting it, I'd really have to know where that is, and the -10.3 tells me more about that. The last one we need to find the x and y intercepts is g of x equals x squared minus 10x plus 24. Again, with the x-intercept, we let y, or in this case g of x, be 0. So 0 equals x squared minus 10x plus 24. This is a quadratic. We can solve it by factoring. So 0 equals x minus 4 times x minus 6. You set each one of those equal to 0 and you get x equals 4 and x equals 6. So you get two x-intercepts, 4, 0, and 6, 0, which is not a bad thing. We saw more than that in some of the graphs that we just made up above. And then for the y-intercept, we'll let x equal 0. So when we plug 0 in, we get 0 squared minus 10 times 0 plus 24. So eventually we get y is just 24. So that y-intercept is 0, 24. So all of these are different types of functions, as we'll see later on, but technically we got a simple function here. A was linear, B is a radical, and C was a quadratic. So all different types of functions, but the theory and how we find these intercepts is the same for all of them. The solving techniques are a little bit different, so that's just something you've got to recall from algebra. All right.